Hello everyone, welcome back to my channel. So as we have discussed that today we are going to learn about arrays in Java. So before going directly to the topic, we'll just have a quick recap that what data types we have discovered till now, because by that we'll be able to understand that what is the need of arrays. So when we were starting with the data type, I said that there are two different kinds of data type. One is primitive, another is non-primitive, and I said that for now you have to only worry about primitives, and non-primitives we will be covering later. So we have discussed all the primitive data types, and I hope you all have a clear understanding about what are primitive data types, for example int, long, float and all. So we have completed the primitive section. Now today, see, from now onwards, other than this 8 primitive data type, whichever type you see is a kind of non-primitive data type. And non-primitive data type, as I said, that they are user defined and accept string. So we'll see strings as well, don't worry. And for today our topic is arrays. So anything from now onwards other than these 8 primitive data type will be of type non-primitive. Yes, but now again non-primitive won't be that much clear today, but it will get clear and clear as we proceed. So non-primitive data type, as I said, they are user defined and arrays are one of them. So today we are going to understand what are arrays and why do we need that. So before proceeding to arrays, first we'll again have a recap that why do we need a data type or why do we need a variable. So the answer might be I need a variable a for storing some values. So I want to store this value, so I used a variable a. So to tell the compiler what kind of value is this, I used a data type. Correct. So I used a data type, for example int. So a is just a name to my container. It is just a variable that holds this value. In actual, this value is stored in the memory address and this a is pointing toward this memory address. So correct, I need to store a data, I used a variable. What if I want to store a large amount of data? So let's say I want 100 different numbers. Will it be very easy for us to store them in a 100 different variable? And if yes, okay, will it be easier for us to memorize all this variable like a1, a2, a3? No, it will be not that good and it won't be a best practice that we can follow. So now, is there any alternative to make this task easier? Our question might be this, like I want to store values from 1, 2, 3, 4, 5 and till 100 or 200 or 1000. It's up to us. Okay. Now, what is there any alternative of without creating these variables like this? Because if I do this, I have to declare it like int a is equals to 1, int b is equals to 2 and so on. So it will be very difficult or it will be very cumbersome for us to perform this kind of variable declaration. So that's the reason why the arrays came into the picture. Now we'll see how do we declare arrays and what are the advantages of using arrays. So now let's proceed with arrays. Alright, so arrays, as I said that I need to store large amount of data of the, for now I said that numbers from 1 to 100. So are this number of the same type? Yes, because all of them are integers or all of them are fixed number. So which means these are homogeneous data. So arrays can hold only homogeneous data. So I cannot have 1 and 1.2 in a int array, because if I declare a array as of type int, which means it can store only int data types. So it cannot store 1.2 in it. So we'll get an error that hey, there is a type mismatch, I cannot convert from double to int. So just keep this in mind that arrays can store only homogeneous data. So if I want to store 1 to 10, okay, so like this 1, 2, 3, 4, 5, is there any way to do that? I'll say yes, you can store these values in arrays. So how do you declare an array? first we'll see what is the syntax of declaring an array, then we'll again see how we can perform some task on arrays. So let me declare a array. See, this is the way we used to declare a variable like 10. So now I need to make some change so that our compiler understand that a is not a simple variable, it is a kind of array. So what changes we made in the syntax, I can give square brackets. So as soon as I give the square brackets, it says that this a is a kind of array. So now there are few different syntaxes for declaring array, and we'll see each one of them. So first thing that we need to keep in mind, that for declaring array we use square brackets. So it's up to us whether I use square brackets over here or I can use square brackets with a as well. So it's up to us, it's based on your ease. You can use any one of this way. So this is just the styling, it's up to you. Now we'll see how do we declare an array. So now the first syntax that we are going to learn is declaring an array like this. So I'll say, again don't worry about this new keyword, we'll see new keyword when we move to objects. So as I said, non-primitives, we'll again see what are objects, and it will be more clear that what are non-primitives when we deal with the objects. So don't worry about the non-primitive type for now. So the first way is I am declaring an array of type int. So this is the syntax, just get used to this syntax. And over here I am saying that this array which is of type int is having a size of 7, which means I can store only 7 elements. Okay, I can store only 7 elements. If I have 8 elements, it won't get inserted inside this. So I cannot store more elements other than 7. So only 7 elements. So it's up to you which 7 values of int you give. You can either give 20, you can either give 1, you can give 30 or 1, 2, 3, 1 to 7. It's up to you, but you have to give 7 values of type int. And if you don't give any value, it gets the default value of this type. So what is the default value of int? It is 0. So for now all these variables are, or I can say all the values, all the 7 values are 0. Now you need to reinitialize them and you need to give them some value. So let's practice this example and then we'll see what happens behind the scene. So let's move to the Eclipse. Okay, I have created a class named as arrays. I declare the main method. Now as I said, I need to declare a variable that can hold many values. So I use the square bracket syntax. First syntax, yes, I can use new keyword, new int, and I need to give the size. So I can give the size as 7. Now your question may be, how can I change the 7 elements, or how can I give values to these 7 elements? Now again let's move to this slide and we'll again practice something, that how memory gets allocated to it. So if I say I have defined a int array of size 7. Now what happens behind the scene? In the memory there are 7 blocks allocated. So these blocks are consecutive, correct? You can see this: first block, second block, third block, fourth block, fifth block, sixth block, and this is the 7th block. Now one thing you need to keep this in mind, these blocks are not numbered as 1 2 3 4. These are numbered, or I can say that indexed as 1 0 1 2 3 4 5 and 6. So if the length of the array is 7, we have indexes from 0 to 6. So just keep this in mind and don't confuse with this indexes. So indexes in arrays always starts with 0. Now if I want to point this memory location, see, for assigning or for declaring any value or for storing any value for at a particular memory location, I used to point to a variable, right? Like int a is equals to 10. So I used to point, whenever I want to initialize a as 20, I need to point a, correct? So I used to point a, which goes to the memory, okay, and this will go to this memory location where 10 is there, and now I can initialize it with 50, or I can reinitialize it with 100, so it gets changed to 100. So this A is doing what? This is pointing to that particular memory location. But now at our example, int A is equals to new, or yes, I need to give the square brackets as well. So now A, but now A is pointing to, or A is pointing to this location, and this location have 7 values, so this will give only the memory address. I need to point this particular index, so I can use the square bracket syntax. So as soon as I give 0, this says that you have to point to this memory location, and inside this memory location, this 0 will say you have to point to this memory location. So now what happened? You can reinitialize its value to 20. It's up to you. So as soon as you do this, it gets 20 over here, and for now all of them are having zeros. Yes, so now if you want to change this, see in the chat box you give me how can I change this. Till then I'll try to change these two values. So if I want to change this, what I can do, A of index 1, so this will point to this location and this one will point to this location, so I can change it to 30. Yes, now if I want to change this, I can say A of 2 and change it to 40. Yes, Suraj, don't worry about the new keyword. We'll understand that what is new keyword when we go in the object section. So for now, don't worry about that. So you just give me the how can I assign value to this position. Now if I want to change this, how can I do that? A of 3 and I can give the value as 50. No, Praveen, your answer is wrong, because what I said that if the length is 7, this can hold 7 elements, but the indexes starts from 0 to 6 only. So indexes lies between 0 to 6. So I can give A of 6 because I started pointing to this array with 0th index. So A of 6. So now this 6 points to this memory location, and I can assign any values to this, like 70. Is that clear to all? Yes. So as soon as I do this, this gets the value of 30, this gets the value of 40, this gets the value of 50, and this gets the value of 70. Yes. So now let's practice this one as well, and if it works fine, then great. So how can I do this? A of 0 equals to 20 and A of 1 equals to 30, A of 2 equals to 40, A of 3 equals to 50, A of 4 equals to 60, A at 5 is equals to 70, and A at 6 equals to 80. Now one thing again, keep that in mind. If you try to system.out.println A, let's see what happened. Let me run this. See what output do we get. See, so this is not, and means this is not the output that we expected. So as I said that A over there, that A was pointing to that particular memory location where our array is present. So this is our array, this is pointing to this. If I want to point to each of them, I need to give the indexes. So if I want to print this element, the first element, I need to give the 0th index. So this is something that we need to understand, that I cannot print the A directly. I need to call that particular element or that particular index to print its value. So I hope this is clear to all. So let's move to Eclipse again, and if I want to print 70, See, again in the chat box, you need to give me how can I print this 60. Till then I'll print the other data. So if I give 0, what will it print? 20. Is it the correct value? Yes, because a of 0 is now having 20. Yes. Now if I want a of 1, how can I do that? A of 1. So now what this will print? This will print 30. Now no, we won't get any error because a is still pointing to something, and that is the memory address where our array is located. So we won't get any error, but we won't even get the actual output. Yes. Now for printing 50, I can say array at 3. Yes. A4 for printing 60. Absolutely right. So A4. Yes. So I hope this is clear to all. Okay. So now what I did, system.out.println just a second, and a at 5. Now what will happen? See, as I said, this is of type int. So I have just given the value for starting 5 elements, but for the next 2 I haven't given any values, but for them it will always get the default value for the particular data type, and in our case the data type is int. So if I do this, then to the last 2 element gets this 0, as because they have the default data type as, or default value as 0, because for int the default value is equals to 0. So I hope this is clear. Now one thing, or your question may be, what if I try to point 7th index, even though it is not there, but what will be the output? Correct. Now the 7th index is not there. Now whenever you try to give the index beyond the actual index that the array have, okay, so now the 7 is not there in our array, we'll get an arrays index out of bound exception. Just keep, if I try to run this, see, it will print this, and at the line number 19, as soon as we try to go to the 7th element or 7th index, it says that there is an exception called as arrays index out of bound exception. So when you try to go beyond the index of a particular array, then we get an array called as array index out of bound exception. So just keep this in mind. Whenever you get this error, you should be able to click that yes, I am getting this error, which means I am trying to point the index that is not there. Okay, so now one more thing you need to understand, that what happens at the declaration. Yes, now we just had a rough idea that a, okay, I'll just give the actual new int 7. So now this a, I'll just clear it little bit after some time. So we have just cleared something till now, that yes, the a is pointing to this location, and inside it is having indexes like 0, 1, 2, 3, 4, 5 and 6. So these are the indexes inside it. But now how the actual memory allocation takes place. So let's say this 0 is located at x position. So now this will, as I said, this is consecutive, so you cannot say that it is at x plus 1. It is not as x plus 1, it is x plus y, and this is at x plus 2y, this is at x plus 3y, and x plus 4y, x plus 5y, and x plus 6y. Now your question may be why? Yes, so now your question may be why there is y over here, why it is not x plus 1, x plus 2, because if it is at 100, then why it is not at 101 or not at 102? So do you remember what is the size of, see, first we'll see what is y over here. So y is the size of the data type, or the the size of the data type that we are using. So what is the size of int? We'll say 4 bytes. So if x is at 100, which means from 100 to 103, these are blocked for only the 0th index, correct? Because it is having 4 byte of space, so this space is only allocated to 0th index. Now the next index will have the range from 104 to 107. So this is nothing but, if this is x, then this is x plus y, because y over here is 4 byte, because for int it is 4 bytes. So if I am using long, then it will be x plus 8 byte. That is, if the starting index is at 100, then the next will be at 108. So I hope this is clear to all. Yes. Now one more thing that you need to know is arrays, or I can say that all the objects. See, arrays are also objects, and we'll see what are objects. So for now we'll say that objects get stored at heap. Now again, heap, you don't have a understanding of what is heap, so don't worry about what is heap, but for now we can say that it is a special kind of memory where all the objects, even arrays, get stored. So you just need to point this, and in our next session when we deal with the objects, we'll understand what is heap and how actually the memory allocation takes place. So don't worry, but for now you can say that arrays are stored at heap memory. Yes. So now we have covered how do we point to a particular index, how the indexes starts in array, and how do we reinitialize the indexes. If I want to change arrays 4, how can I change it? I can again point to this particular memory location. I can say 78. So instead of 60, we'll get 78 as the output over here. Yes. So we have seen that how I can reinitialize the array. Now we need to understand. Yes. So after this, I'll tell you that there are another syntaxes as well for declaring the array. Over here, what we were trying to do, we were trying to declare an array for a particular size, and then we were entering each index of that particular array, and we were giving the values to the, or we were giving the data to it. Now what I'll do is, instead of doing this, or instead of giving the size over here, and instead of performing this task, okay, I'll just create another array. Yes. So I'll comment this int, I'll say it is a kind of array named as a. Now I'll use the new keyword, new int. Yes. Now instead of giving the size over here, what I'll do is I'll directly define the data to it. Now what happens, this data gets stored inside this array. Now how, okay, I'll give another two data as well. Yes. So now how many elements I have stored in this array? We will say there are 7 elements. So what is the size of this array? It is 7 for now. So from where the index will start, 0 up till 6. So I can fetch the elements of it. But now, is it easier for us to declare the size or to declare the data to it? Because previously we were using 6 different line or 7 different line for the same task. So now I can do it in a single line. So over here I can give the elements if I know the elements that what I want to store inside the array. See, I can give the elements directly, and the output comes out to be the same that it was for this. So it works same, both the syntaxes work same. So we can say that this way is a shortcut for declaring an array with respect to this. Now the third way is again a shortcut, and which is shorter than this one as well. So let's see that as well. So if I say int a is equals to, see, now in the third way I don't have to use any new keyword or any int at the right hand side. I can just directly give the data to it. So if I pick this data and put it over here and let me run the same program, see, the value comes out to be the same. So again it is performing the same task. So obviously the third one, or the third way of declaring an array, is the shortest among them, correct? So we'll often use this way only, and yes, this way is again used when we just know the size and when we give the data after some time, or after, or in another program. So both of them are often used, so don't worry about this, but this is the shortest among them because we don't have this task to do. Like I don't have to call each index and give the size or give the data to it. So it will be easier if we know the data to it and we can give the data directly to it, and we can call it the same way that we used to call. Now to get the length of the array, see, now I have given you this array. I want you to, hey, tell me the length of the array. How can you tell me? Now you will count it. 1 2 3 4 5 6 7. Okay, there are 7 elements, so the length of the array is 7. Now what if I gave you an array of 700 elements? Will you count? Yes, you can, but it will be very difficult. So what I can do is a dot length. So there is a length. I can use this length after this. So I can use the array name, array name, and I can use the dot operator, and I can give the length. So this syntax gives us the length of the particular array. So the array is A. What is the length of A? It is 7. So will we get 7 in the output? Yes, we get 7 in the output. So yes, so this way. Did you use middle bracket? No, not length dot A. It is A dot length. Yes. So which says that A dot length means I have to return the size of this array, and the array over here is A. So it gives the size of A. Now what happens in the memory actually? We'll see that one as well. So yes, now as soon as I say this, okay, this is an array. Let's create an array. How many elements are there? 7. Let's fix the size and give 7 elements to it. So is the size fixed over here? You will say yes, it is fixed. So if it is as x, it will be at x plus y, x plus 2y, and so on. Okay, so now this is one disadvantage of array, or we can say this is a limitation of array, that array size is static. I cannot change, I cannot increase its size, or I cannot reduce its size. Can I reduce the size of the array now? Well, because it cannot be done, so I cannot do it. And can I increase its size? I cannot. Now the reason for this, can you guess that? As I said, array get the memory allocated as soon as I declare it. So now if I declare int a is equals to new int 7, now in the memory 7 element means 7 spaces are allocated to this. Now this a points to this whole location. Now let's say this is at x and this is at x plus y, 2y, 3y, 4y, 5y, 6y, and 7y. Okay, so this is at x plus 7y, so it is at 100, so it will be at 100 plus 7 into 4, that is 120th location. It will start from this. So now let's say, okay, so it will range from 131. Yeah, so now let's say after this line I have declared another variables as well. Int b is equals to 20, int c is equals to 30, long d is equals to 40. So there is a possibility that this B, this C or this D can get stored at memory address 132 to 135. So this B, let's say the B is stored at this position. So 20 is here and C is over here. So 30 over here and D is at this. So 40 over here. Now if I try to resize it, as I said that arrays elements are always consecutive, that is one after the another. So is there any space available? Is there 132 available to store another variable? No, I cannot store another variable after this because this space might be occupied by some other variables. So that's the reason why we can say that this is the one reason that why arrays are static in nature, why we cannot resize it. So this is the way from which we can remind the concept of array, because this position 132 might get allocated by some variable or by other variables. So I cannot resize an array or I cannot reduce it. So this is the property of an array, and we can say it has a limitation that I cannot resize the array. So that's the reason why we have concept of collections or we have array list. We'll see that later, but for now we need to emphasize on arrays. So I hope arrays is clear to everyone, that how memory allocation takes place and why arrays are static. So can I change the array size after its declaration? The answer is no. So how do I fetch the length of an array? Using the dot length. And how to point to a particular location? So for example, I want to point to this, so I will start indexing this. So I can say that A of 3. Yes. So now is it easier to fetch or to retrieve element from an array? Answer is yes. Now previously what used to happen? Now we will have an idea that means about the complexities from now onwards. So it will be easier when we move or when we proceed further. So if I have 20, is it easier to fetch the 20 after 10 lines of code? So let's say I have used this. Can I call A and is it easier to fetch this value? So let's say system.out.println A. So will it easily get this value in a constant time? Like will it have some extra work to do? You will say no, there is no extra work. A is pointing to some memory location. I just need to call this value and just need to print this value. So the same goes for this array. So let's say I have declared this. So now let's say yes, so for now int 7, yes, 7 boxes. First is at x, then plus y, 2y, or I can say x plus 2y, x plus 3y, x plus 4y, x plus 5y, x plus 6y, and last at x plus 7y. Okay, so now what will happen if I want to fetch this element? Okay, this is the 0th element, first, second, third, fourth, fifth and sixth. So if I want to fetch this element, what will happen? It will use this formula internally, x plus 3y. Where is this memory address? Stands for int, the size of int, 3 into 4, that is 12, and x, the memory location of this, it will start from this. So let's say it starts from 100, so it will directly point to 112 position. So now let's say I have 700 elements in my array. It will take the constant time because it has the formula like this. Like for the 700th element, it will use x plus 700. It won't go to each and every elements like this. So that's the reason why retrieval using arrays is very fast. Yes. So is it clear to everyone? Yes. So yes, arrays are really very fast. So this is an advantage of using an array. I can store homogeneous data. I cannot store heterogeneous data. I can store only homogeneous data, but I can store a large amount of data as well in a single variable or in a single unit. So it is again an advantage. The retrieval is faster in array. Yes, so the limitation for array is it cannot be resized. So once the array is declared, its size is always fixed. So now let's proceed further. So I hope it's clear about, means all the concept for one dimensional array is cleared. Over here we just had a one dimensional array. This array int a is equals to new int 7. So this is a one dimensional array. Is there any other dimension for this? No, it is a simple diagram for this array. So this is a one dimensional array. Now we'll see two dimensional array. No, we don't have to declare any formula. I just gave an understanding. Okay, we'll again have a recap for this. Int a is equals to new int 7. So now let's say this a is pointing to a memory location, or it is having the start from 100. Okay, now there can be 7 elements in this particular. So for the first element we just call this 100. For the second we need to call 100 plus y, x plus y. For the second, x plus 2y, x plus 3y, x plus 4y, where just a second, x plus y, x plus 2y, x plus 3y. Yes, so where yeah, so over here where this x is our starting point, this, and this y is our size of the int variable. So for int it is 4 byte, so which means I have to point to 104. So now let's say, see, now you can get the formula. This is at index 0, 1, 2, 3, 4, 5 and 6. So if I want to fetch this value, whose means what multiple of y I can call? 1, because the same as index x plus y. If I want to call this, so I can use 2y, that is x plus 2y. So if the compiler need to call at 659th element, so it can call the starting element's address and 659y. That's it. So if I say a 659, let's say there are 700 element in a, and if I say a 659, which will, this formula the compiler will use internally. See, you don't have to memorize this formula or anything like that. I'm just giving you an idea that how memory gets allocated and why retrieval from array is very fast. Yes. So now let's proceed further with two-dimensional arrays. So now for declaring a two-dimensional array, first we'll see the way we started with the single dimensional array. So again, first we need to declare a 2D array. I need to give some type, or I need to give some size. So if I give 3 and 2, now what happens behind the scene? See, there are two size I have given. Okay, so now the first size says the actual size of this a. A will point to this area where this array is there. So this array is having 3 parts, or I can say 3 elements in it. So a will point to this location, and internally what will happen, this 2, by using this 2, this says that each element is further divided into 2 parts, or I can say that this array internally have 2 parts. This have internally 2 parts and this have internally 2 parts. So altogether how many elements I can store? You will say 3 into 2, that is 6, because internally each compartment is divided into two parts. So if this can hold 2, this can hold 2, this can hold 2, which means I can store 6 elements in it. So which gives us the combination of 2 to 2 element in each compartment. Okay, so now let's say I have a bigger array than this. Int a is equals to new int 5 comma 3 or 5 and 3. So now a will point to the actual array 1, 2, 3 and 4. Now each compartment having 3 parts. Now I'll help you to point to each part. Now your question will be, how can I store value to each compartment? Correct. So we'll see that how can I store the values to each compartment. So first I'll show how can I store for this compartment, or I can say how can I fill this compartment. Then you are going to tell me that how can I store this. Okay, just give me the answer in the chat box. For now I'll just explain how can I fill this box. So a points to this location and the index starts from 0, 1, 2, 3, 4. Correct. So I need to point this compartment first. See, there are 5 compartments. So first I need to point this compartment. So I will say, hey, you have to go where A is pointing, and then you will have some compartment. So you have to go inside the 0th compartment. Now inside the 0th compartment, which compartment you want, because it is further subdivided into 3 compartments. So you have to point this one again internally as well. There are indexing from 0. So I will say 0 of 0, I will fill it as 10. Then I need to point to this. I will say again, hey, you have to go to the 0th compartment. Now you have to go to the inner first compartment. So I will fill this as, and then for the next one equals to 30. So now you give me the answer for this one. Yes. So now if I want to fill this compartment, so where it is located, I'll say it is located where A is pointing. Inside the A, you have to go to the second compartment first. So second compartment, and in the second compartment you have to go to which compartment? The first compartment. So this will point to this compartment and I can fill it as 75 over here. So can you give me the answer for this? Yes. Now I'll again have, I want to go to this compartment. I have to fill some values over here. So which compartment I will go first? A is 3 and then 0, 1, 2. So I'll go to the second compartment of the third major compartment. So now I can give the value as 65. Yes. So someone is saying that A is 4, 0. So this equals to 40. See, now this will do what? We have to go to A. Okay, A is pointing to this 5 compartment. I have to go to the 4th compartment. Great, we are here. Now I have to point to 0th compartment. So this points over here. So 40 will get assigned over here. And then 4, 1. Yes, so then again 4 and 1, which will give the values over here. That is 70 and 4, 2, and 4 and 2, we can say that A, 4, 2. This will point to this location. Yes. Correct. 4 and 1. So for going to this location, I can say A is 4 and 1. Yes. Yes. So someone is saying that A4, 2, A3, 2. See, index starts from 0. So you have to go to the last compartment, that is 4. So I am going to call the 4. Now inside the 4, I need to give this compartment, the second, but still the indexes have the indexing as from 0. So I need to give 4 and 1, which will give us the value over here, that is 70. So I hope this is clear to everyone. Yes. So what we can say that 2D dimensional array is a big array which internally have sub arrays. Correct. This array this is an array of size 3 which is an sub array for this particular compartment. So even in train we have compartments, right, like A1, A2, B1, B2, and these are the seats for it. Okay, so I hope this is clear to all. Correct. So your question is how we get to know the value of every compartment. Okay, I'll explain this and then you are going to answer me some question. Now I am not providing any indexes to it. 1, 2. Okay, this is further divided into two parts, or let me expand this. 1, 2, 3, 4, 5, 6, 7, 8, 0, 13, 4, 9, 12, 1, 0, 6, 65, 78, 9, 19. So now I need to call this 0. Okay, now our aim is to call this 0. Let's say the array name is, no, not A, for now we'll take X. So let's say our array name is X. How can I go to this position? See, I'll explain you for this position, then you are going to give me the answer for this. Okay, how can I print this 7 over here? Okay, so now let me tell you how can I call this 0. So I need to first call the X, correct, because this is the array that we are working on. Now inside the X I need to give some major compartments. See, first we need to give the compartment. Okay, so let's say the compartment index starts from 0, 1, 2, 4. Which compartment we are interested in? The third. And inside the third compartment, which seat we are interested in, or which inner compartment we are interested in? 0, 1, 2 and 3. So we are interested in the second compartment because 0 is over here. So if I say system.out.println this will give us the result as, or this will give us the output as 0, because 0 is present at this particular memory location. Yes, so now you give me how can I call this 7 in the console. How can I print this 7 in the console? Write me the answer for this. Till now I'll explain how can I invoke this 78. So I can call 78 present in 4th, and of 4 it is present in the 0, 1, 2 and 3, that is first compartment, and these compartments are of which array? X. So if I print this will give us the output as 78. Okay, your answer is x1 comma 2. So let's see, x1, okay, we are over here, comma 2, 0, 1, 2, absolutely right. If we say x1 2, we'll get 7. See, the way that we are learning over here, the same way compiler is going to find the values, because he doesn't know that how, where the values are located. He'll again fetch the X location. Okay, X is having this many compartment, in we have to go to this index, and inside that we have to search for the inner compartments. Yes, so now I hope till now we have a clear idea that how can we declare array, how can we invoke each and every element, or I can say each and every space of this particular compartment. So each compartment is having their sub compartment, so I can say that each array element is further divided into sub arrays. So this is the sub array for the 0, this is the sub array for first index. Okay, now my question is, let me define it again. Int sorry 7 comma 3. Each compartment into 3 parts. So I have created a 2D array having inner compartments, and each compartment is having 3 parts. So now what is the length of this array? Can anyone guess? So the length for this array, as you would have already guessed, that it is 0, 1, 2, 3, 4, 5, 6. See, this is our major compartment, or this is our major array. So we have to always give the size of the actual array. So the actual array is only 0 to 6, that is 7. So the length of A, if I say A dot length, it will give us the output as 7 only. Though we can store 7 into 3, that is 21 elements inside it, but the length is 7 because these compartments are inner compartments of this particular compartments. They don't have their only, means they don't have their individual address. They are the inner compartment of this. If I cannot invoke this 0, I cannot invoke this 3. So that's the reason why whenever I say a dot length, we'll get the output as 7, because we have to work, or we'll get the output for this actual array. Now one more thing that I need to tell you, that over here, let's say this is an array of 4 size, and internally it is divided into 3 compartments. So now see, this is the visual representation that I have given you. What happens actually internally will be like, this is our array of size 4. Internally it will be divided into 3 parts. So now can you tell me the size of this array? It is 4. So that's the reason why we get size of the bigger array, because Java only knows this array, and it internally is divided into indexes, or internally it is divided into arrays. So but the actual array is 0, 1, 2, 3, that is of size 4. So that's the reason why if I say x dot length, we'll get an output as 4. Yes, though I can store 4 into 3, that is 12 element inside it, but this is the capacity of element that this array of length 4 can hold, but the actual length of this array is 4. So let's move to Eclipse. I know it's too much of theory, but again it is necessary. Yes, so if I say int to square brackets x is equals to new int, I need to give the size to it. So I can give the size as 5, 2. How many elements can I store over here? We will say 10. What is the length? 5. So first I'll point to 0th index and the 0th element, and I'll give value as 90. Let me copy paste all this. I'll just give 4 values to it. 1, 1, 2. Okay, let me create little bit of confusion as well. Can I do 2 over here? No, because internally it is divided into 2 parts, and both of the parts will have index as 0 and 1. So I cannot give 2 over here. If we try to give 2, we'll get an array called exception called as array index out of bound exception. And let me change the values as 60, 78, 934 and 56. So now what will happen internally, as soon as I declare this array, yes, as soon as I declare this array, what happened? Okay, there is a array of size 5, each having compartment 2. Yes, but now what I did, as soon as I declare this, what will happen? Each of them will get the default values 0 0, but now I am trying to reinitialize the values. So if I say x 0 1 2 3 and 4, so x 0 and then to the 0th index, so I am pointing to this, I want to assign 90 over here. So now this gets changed to 90. Now 1 and 1, so I want to change this, so this will get changed to 60. Then 2 0, I need to change this to 78, so this gets changed to 78. Then again I comes to 0 and zeros 1, so I need to change this to 934, and then 4 1, so I need to change this to 56. So I hope this is clear to all. Sachin is asking that when we'll start string. So we'll start string, but before that we need to understand what are objects and all. So don't worry about strings. Yes. So now see, compartments are the concepts that I have means that we have made for understanding the actual working. Internally it works in the memories only and in the binaries only, you know that, but the compartments we have made for making it understand better. See, your class 12, you are asking that instead of printing particular element using indexing, if we want to print whole array at once, how to do that? See, for now I'll say that we cannot do it at all, but later when we proceed we'll see how can we use loops, how can we use different methods or different data structures. So for now don't worry about that, we'll see each one of them. So I have changed these two values, over here 1, over here 1, over here no values I have changed, and over here the 1. So if I want to point to this, I can say that x 1 and 1, so this will give us the output as 60. So let's try this, and if it gives us the output as 60, then we have successfully completed the concept till now. Yes, so we have the value 60 that we decided over here. So I hope it is clear to all that how can I call the values and how can I change the values. So if I try to say system.out.println x dot length, what output I'll get? I'll get 5. I won't get 10 because the actual capacity is 5. So I hope this is clear to everyone. Yes, you didn't understand the output. Okay, so now what happened over here? Just yes, so over here I was trying to change some values inside this. So let's say five big compartments, each one is having 2 inner compartments. Yes, I am trying, and each of them gets the default value as 0. Now I try to change 0th index 0th element. Okay, so all of them have 0 1 0 1 internal separations. Yes, like this. So I want to change 0th index, 0th element to 90. So this gets changed to 90. I want to change first index, first element to 60. So this gets changed to 60. Then I change second index, 0th element to 78. So this gets changed to 78. Then I try to change 0th one, that is 0th one, that will be 934, and then I try to change fourth first element. So fourth first element, that is this. So this will get changed to 56. So now if I try to print this 1 comma 1 means first element of first index, so it will go over here and it will then go over here. So this will print 60, and that's what we have got. So if I try to print this, we'll get 0, and we'll try this one as well. So I hope it is clear till now, and let's try to print that 0. Yes. So if I go over here, system.out.println x 1 and 0, let's see what we get, and we have got 0 over here because we haven't initialized this yet, and it gets the default value, that is 0. So yes, I hope this is clear to all. So now, okay, so we have covered till now how do we declare one-dimensional array, how do we declare two-dimensional arrays, and there are other concepts in 2D arrays that we can declare 2D array in a different ways as well. See, in the 1D array we have 3 different ways to declare the same array. So in 2D arrays as well we have different methods, and we'll see that. Okay, so let's try the first one. This was the first one that we practiced. Now instead of using this, I can also have something like I can just directly give values to it. Now see over here why I have given curly braces internally as well. For one-dimensional array it was direct, right? 1 comma 2 comma 3 comma 4, which means the array size is 4. But now in 2D array I have to give internal compartments as well. So if I want the actual length of the array as 3, so I will be having 3 pairs of braces like this, first, second, and the third. Now I want to give data to each one of them, so I can give 20 comma 30, 40 comma 10, 1 comma 2. So now this will work same as this. Okay, so now let us visualize this one as well. So int x is equals to 10 comma 20 comma 1 comma 2, 14 comma 13. So now how this will work, there is altogether how many curly braces or opening and closing curly braces except the bigger one? There are 3 pairs, so which means there are actual 3 compartments. So the length of x is 3. Now I want each first compartment of 2 size, and the first element is 10 20. I want second as size 2 and the third as size 2 again. So it's up to us. See, using this syntax we have the flexibility. Using this syntax we get the flexibility that how many elements I want to store at the particular compartment. So let's say I declare the 4th compartment and I don't have 2 but I have only, or I can say I have 3 elements, 1 3 10, or let's say I have 4 elements inside it. So now over here in the 4th compartment how many inner compartments I will have? You will say 4. 1, 3, 10 and 14. So this gives us the flexibility. This syntax gives us the flexibility of declaring the 2D array with different size of inner compartments. See, over here 2, 2, 2, but over here we have 4. So altogether we can have 10 elements inside this particular 2D array. Now to fetch this 10, how can I go? 0, 1, 2, 3. So x is 3 and then 0, 1, 2, 3. So I have to fetch this 10. So I can say 2. So this will give us the output as 10. Yes, so you are asking that can I really reinitialize variables, or can I reinitialize this 1 to 10? Yes, obviously you can do that. See, in our example as well, we have seen this over here. I changed 60 to 78 for the same element. So you can do that. It's up to you how many times you choose to perform the same task, or how many time you perform the initialization or redeclaration for that particular element. So it's up to you how you change it or what value you give, but it always gets the default value as well. So I hope this syntax is also clear. Let's practice this. So instead of doing this, int x is equals to, I can give, see, the first compartment, second bigger compartment, third major compartment, fourth and the fifth. Now this reduces our work for initializing each element like this. So over here, if I have 5 compartments, first compartment, let's say I have only one value, second compartment, let's say I have 2 values, third compartment, let's say I have again 2 values, fourth compartment, let's say 3 values, and the third last compartment, let's say 5 values. So how many values do we have for now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Correct. So I have altogether 14 elements over here. But if I would have used this syntax limits the compartment, that is the inner compartments, and also this syntax, using this syntax, if I have to perform the same task, I would have ended 14 lines of code for performing the same task, because I want to initialize the 14 elements. So again, this is the shorthand for declaring 2D arrays. And now if I do this, what output I will get for this? What output I'll get? The length is 1, 2, 3, 4 and 5. So the length will be 5. And if I try to point first element, so that is, this is the 0th index, so we don't have to go into this. This is the first, so I want to go inside this and I want to print 7, because 7 is at the first position. Yes, someone is asking what is public static void and system.out.println. We are using this in code. So as I have already discussed, that don't worry about anything that we haven't discovered yet, like public, static, void or string, args. Don't worry about that. We'll discuss each one of this, but we have discussed about how can we make variation in println. Yes, though we haven't completed this sys and out, but don't worry about this, because for now we don't have any clear idea about what are classes, what are objects, what are access modifiers. So how can I explain you about the public? How can I explain you about static and void? We haven't completed any methods as well. So don't worry about this, we'll be covering each one of them. Yes, so now if I say length 5, first 7, and for this we'll get output as 5. See, 7 and 5, and the first one says the length of the array. So I hope this is clear to all. Yes, so there are other variations as well. So for example, if you want to use the previous syntax as well, now your question may be, how can I have this flexibility using this? using this syntax. So what you can do is, as I have already said, that each compartment is internally having several compartments, so you can omit this for now, okay, or I'll say that 3, you can omit the inner compartment like this, and then whenever you want to, okay, now int x is 0 compartment, you have to say that internally it have a new array of size 7, let's say. So this will do what? This will define 7 compartments, 7 internal compartment for the first compartment of this array, and the same you can do for other 2 compartments as well. So this will again give you the variation. We'll discuss this. Yes, so you can use the same. Now what will happen behind the scenes, we'll discuss this. So now what happens over here, okay, this says that x points to a array of size 3, but now we haven't defined any internal compartment, so it will be like this only, okay. But now if you try to, at the line number 37, we say that this 0 1 2, this 0 1 and 2 indexes are there, so at the 0th index you have to define this compartment as a new array of size 7. So this will be like this, and this will be like this, and the last you have defined it as array of size 4. So this will again give you the flexibility like this, but again for defining the variables inside it, you need to perform the declaration lines differently, or you can, instead of doing this, you can say directly define the elements over here. So it's up to you which one you choose. Yes, so you are asking that yes, we will cover this one as well. If we want to print the length of the inner compartment, can we do that? Let's see what the inner compartment actually are. So what the inner compartment are, let's say I have the major compartment as 3, and each of them have compartments like this. So what are the inner compartments? Are they array? The answer is yes. So this inner compartments are array. Can I get the length of array? You will say yes, definitely, using the dot length, correct? So now this 0 1 2 and over here 0 1 0 1 0 1. So can I get the length of this 0, because internally it is having the division like this. So can I get the length of this? So you can say yes. So let's say x of 0 dot length. What will be the length of x0? You will say yes, internally it is having 2 elements, which means its length will be 2. Yes, so now if I want to do this, or want the size of this, so I can say that array 2 dot length. This will again give us the output as 2. So let's practice this. So now over here 0 is having length as 7. So instead of calling elements of it, can I use dot length? And let's say for 2, can I do the same? Yes, so we get 7 and 4, because the length of the 0th compartment is 7, because it is storing 7 elements inside it, and the length of the second compartment is 4, because it can store 4 elements inside it. Why we use new in array? So we have already said that we don't have to focus on new keyword for now. When we deal with objects, we'll see why new is needed. So I hope both the dimensions of array is clear to all, that how we declare a one dimensional array, how we declare a 2D array. Although 3D array is remaining, we'll cover it in the next section, and the most used array is 1D array only, and you can see that 2-dimensional arrays are also used, but three-dimensional arrays are not often used. So we'll cover this one as well in our next session, but if you find this confusing, you don't have to worry about this. We have to be strong in these two kinds of arrays, and tomorrow we'll see what is three-dimensional array, how can I declare three-dimensional array. But for now, I hope all the concept of arrays is clear to you till now. So do you have any doubts? You can ask in the chat box, or you can post your doubts in the comment section. x2.length should be 2. Okay, so you are saying that length of x2 should be 2. Let's see. So over here 2 points to this, and I have initialized, see, first we have x 0 1 2. I have initialized 0 as 7 compartment, and then I have initialized 1 as 2 compartments, and then I have initialized 2 as 4 compartments. So what is the length of this 2? It is 4, because it is able to store 4 elements. It is having 4 elements inside it. So if I try to get the length of it, it will have 4. Yes, you should practice this. Yes, this might seem confusing for now, or it will be difficult to understand, but once you try and practice all this concept, it will be very easy for you to use this arrays in your programs. So I'm closing the stream for now. If you have any doubts, you can post it in the comment section. So thank you all for joining today's session, and